Okay, hello students. In the last class we have discussed what is continuity and the definition of continuity and some properties for continuous function. What are the types of discontinuity? Two types, removable as well as unremovable, non-removable discontinuity. Now we will discuss the algebra of continuous functions. Now what is meant by algebra of continuous function? It means there are two variants. One is just a moment. Yes. What is meant by algebra of continuous functions? Algebra of continuous functions implies we are adding, subtracting, multiplying or dividing two functions which are continuous, or it can be one is continuous and other is discontinuous. So what are the different scenarios possible for that? Algebra of continuous functions. If f of x and g of x are continuous at x equal to a, then c into f of x is continuous at x equal to a. What does it mean? Suppose sin x is continuous. It is continuous in all real number, we already know. That means 2 sin x, that will also be continuous. Minus 3 sin x, that is also continuous. That is what this property means. First algebra of continuous function is if you multiply a continuous function with some scalar number, then that function will also be continuous. Second one, f plus or minus g is continuous at x equal to a. Since f and g are continuous, that means f plus g is also continuous. For example, we can take f of x equal to sin x, g of x equal to cos x. Then both are actually continuous function. Then if we add sin x plus cos x or sin x minus cos x, that will also be a continuous function. That is what this property means. Next, f into g is continuous at x equal to a. Since f and g are both continuous function, then f into g, f of x into g of x is also continuous function. You can relate with this. You can take this constant as first function, that is f of x, and this f of x, that is g of x. Then if you multiply these two, again this is a continuous function. It is similar to that. Only instead of constant, we have any function that is possible for this. So f into g is also a continuous function. For example, f of x equal to x, g of x equal to sin x, both are continuous function. Then f into g, that is x into sin x, is also a continuous function. X sin x is also a continuous function. That is the third property. Then fourth property, f divided by g is continuous at x equal to a, provided g of a is not equal to 0. At this point, this function denominator should not become 0, because when denominator is 0, it is undefined. So as long as denominator is non-zero, we can write f by g is also continuous function. Next property, f is continuous. That means mod f is also continuous. F is continuous implies mod f is also continuous, but its converse is not true. What does that property mean? F is continuous implies mod f is also continuous, but its converse is not true. We will consider one example. Consider f of x is a function defined like this. Y equal to x. Then what is f of mod x? Mod f of x, that is again whatever value is there here, f of x, when it is negative, it is converted into positive. As f of x is continuous, y equal to x, let f of x equal to x is a line. This is a continuous line. As this is continuous, mod of f of x, what is the graph of mod of f of x? Whenever f of x becomes negative, we will take the absolute value of that. So how will the graph of mod of f of x be? when x is positive, f of x is positive, we will have the graph as it is. That means after x equal to 0, this line will represent the same for this graph also, same region. Then for f of x is negative, we need to change the sign. That means whatever value of f of x is coming here in this graph, we need to mirror image with respect to x line. Then we will get the f of x graph. So this will be the graph. What is this graph? It is nothing but mod x, which is again continuous. So what we observe from this question, when f of x is continuous, then mod of f of x will also be continuous. Now what about its converse? Suppose let's define f of x as mod f of x as, consider it like this, mod of f of x. This is mod of f of x. Then what is the possibility of f of x? F of x can be a function which is defined by, say this point is 2 for example. This line represents y is equal to x plus 2. Now mod of f of x will be this graph. Now f of x possibility can be, this represents after f, when f of x is positive, this region could be, this is one example, it is not necessarily the same graph. And this region can be a region given like this, because we are taking mirror image and it will become continuous. So whenever f of x is discontinuous also, we can get mod of f of x as continuous or not continuous. But when mod of f of x is continuous, it does not mean f of x is continuous. That is what this property means. Do you understand, students? I will repeat. F of x equal to x is one example. I am taking one example for demonstrating this property. F of x equal to x means mod of f of x will also be continuous. As f of x is continuous, mod of f of x should be continuous. That is the first statement. But its converse is not true. What does that mean? Mod of f of x. Let's take mod of f of x is a continuous function. Then what about f of x? It is one example for representing this function. This is need not be continuous. So this value could be 2 and this will be minus 2. Then what will you get? This line represents y is equal to x plus 2 and this line represents y is equal to, say, x minus 2. Then these two are discontinuous. So this is the example for mod of f of x. Is continuous, but f of x is not continuous. Okay, next is the largest or greatest integer function of x, that is box of x, is continuous at all points except integral points. We already know what is a graph of greatest integer function of x. We have already learned this in class 11. You have already learned different types of functions and how to draw the graphs of functions. So we will just see y is equal to box of x. This is obviously greatest integer less than or equal to x. That is defined by box x. So this box x will be, suppose x equal to 0.3. Then what is the greatest integer that is lesser than 0.3? That will be 0. So between 0 to 1, its value will be 0. Between 1 to 2, say 1.5, it will be 1. 2.3, 2. Similarly, whenever it becomes integer, that curve will get a jump from different unity integer. So this is the graph of box of x. As we can observe, at all integral points, this becomes discontinuous. So that is the first one. Second, the fractional part function is also discontinuous except at integral points. Now what is the graph of fractional part of x? Fractional part of x has its domain in all real number and range in 0 to 1. 0 to 1 its value will be 0. Between 0 to 1 its value will be 0. Between 1 to 2 its value will be 0. 2 to 3 its value will be 0. 3 to 4 its value will be 0. 4 to 5 its value will be 0. 5 to 6 its value will be 0. 6 to 7 its value will be 0. 7 to 8 its value will be 0. 8 to 9 its value will be 0. 9 to 10 its value will be 0. 10 to 11 its value will be 0. 11 to 12 its value will be 0. 12 to 13 its value will be 0. 13 to 14 its value will be 0. 14 to 15 its value will be 0. 15 to 16 its value will be 0. 16 to 17 its value will be 0. 17 to 18 its value will be 0. 18 to 19 its value will be 0. 19 to 20 its value will be 0. 20 to 21 its value will be 0. Now what is a fractional part? It always lies between 0 to 1. We already know that. That represents the decimal part of a number. For example, 5.7. That means fractional part of x will be 0.7. So that will always lie between this value. 5.7 will be, number will be here. Its corresponding y value will be 0.7. 5.6, it is 0.6. So this always represents a straight line between 0 to 1. Y is equal to x line between 0 to 1. So between 0 to 1, fractional part of x will be x. Between 1 to 2, it will be x minus 1. Between 2 to 3, it will be x minus 2. So this always lies between 0 to 1. As you can observe, whenever it becomes an integer, fractional part of 1, that is 0, 1.0. So decimal part becomes 0. Next is, every polynomial function is continuous on all real number. This is very important, students. This will be very helpful in solving problems for limit as well as in continuity. Whenever we get a polynomial function, what is a polynomial function? It is of the form an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2, etc. So whenever we get a polynomial function, it is continuous in all real numbers. Constant function is continuous on R. That is true. Constant function means its value does not change. For example, y is equal to 2. That is a constant function. So it always remains same. F of minus 5.6, that is equal to 2. F of 2 equal to 2. F of 0 equal to 2. So whenever x changes, y value does not change. So this is an example for constant function. So for all constant function, it is always continuous. Log x is continuous on its domain. That means R plus. You know what? When log x will be defined, whenever x is greater than 0, log of number should be greater than 0. So when this number will be greater than 0, log x is defined. So it's in its domain, log x is always continuous. This is the graph of log x. Log x is always continuous in its domain. Log of mod x is continuous on all real number except 0. Because mod x is always a positive quantity, but mod 0 is 0 and log 0 is undefined. So except 0, we have log of mod x is defined on all real numbers. Therefore, when log 0 will be, it approaches minus infinity. From the graph we can observe. So log of mod x will be continuous except one point, that is 0. This is the graph of mod x, log of mod x. So except at 0, it is a continuous function. Next is, signum function is continuous except 0. We know what is signum function. Whenever x is negative, its value is minus 1. When x is positive, its value is 1. When x equal to 0, its value is 0. That is signum function definition. So for a signum function, when x is negative, its value is always constant. That is minus 1. When x is positive, it is 1. And x equal to 0, its value is 0. So at 0, there is a jump between values. Therefore, this is a discontinuous function at 0. At all other points, it is continuous. For example, in the question, understand or analyze the continuity of the signum function at x equal to 3. That means it is a continuous function at x equal to 3. At whatever point we need to examine its continuity, we have to check its limits and function value at that point, in the neighborhood of that point, right? So, for a signum function, analyze its continuity at x equal to 0. That means it is a discontinuous function. Why is that? Because left hand limit is minus 1, right hand limit becomes 1, and f of 0 is 0. So left hand limit, right hand limit as well as function values, all are different values. So it is a discontinuous function. Next is sin x, cos x, e power x graph we can see. So e power x is defined on all real numbers and it is a continuous function. Mod x, we already know how to draw graph of mod x. These are all continuous function on all real numbers. So sin x, cos x, e power x, mod x, log x, everything is continuous in its domain. Tan x, we know tan x graph, it is again a continuous function except pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2. So what are those values? Odd multiple of pi by 2. So tan x is again a continuous function, but at pi by 2 tan is not defined, therefore we can say this function is continuous in its domain. Tan x, secant x. Secant x graph is given by this. So again, this is again a continuous function in its domain. At pi by 2, 3 pi by 2, 5 pi by 2, this graph is undefined. Secant x is undefined. So except those values, it is continuous. These are continuous on r minus odd multiple of pi by 2. Next is cot x. Again, when we observe from the graph, cot x is a continuous function except at 0, pi, 2 pi. So what are those values? N pi, integral multiples of pi. So cot x, cosecant x graph is again given like this. So these are all continuous functions on r minus n pi. So except at n pi, integral multiples of pi, on all other values, this is a continuous function. All polynomials, trigonometric, exponential and logarithmic functions are continuous at their domain. What does that mean? Sir, from the graph we have seen that tan x is discontinuous at all multiple of pi by 2. That is what is given here. Secant x, cot x. But in this note we have given all trigonometric functions are continuous in its domain. That means first we have to understand what is the domain of this function first, because tan x is undefined at this point. Because it becomes infinity, tan x is not defined at odd multiples of pi by 2. Therefore, when we say it is continuous in its domain, that means at whatever values of tan x that is possible, at those places it is continuous. That is the meaning of this statement. Similarly, not just trigonometric, polynomial function is continuous in all real number, that is its domain also. So all polynomials, trigonometric, exponential is continuous in all real number, logarithmic function which is possible when number is greater than 0. These are all continuous function in its domain. If f of x is continuous and g of x is discontinuous, then what will be its sum? Until now we have discussed in algebra of continuous function, when f and g are both continuous function, when we add it is a continuous function. What about this case? When f is continuous and g is discontinuous, what about f of x plus g of x? Can you guess? For example, x equal to sin x, g of x equal to box of x. We already know greatest integer function is discontinuous at integral points. Let's take f of x equal to sin x and f of x equal to sin x, and this is box of x. Now if we add these two, it will be continuous or discontinuous? Obviously it will be discontinuous, because whenever we have a point, it is a continuous x. F of x is continuous, sin x we already know. Box of x is a constant between 0 to 1, it remains same. So we will have to define this function, to understand the continuity of this function by breaking into different intervals in which these functions are continuous. Only then we can analyze its continuity. So what we do, sin x is continuous on all real number, so we don't need to bother about this. What about box of x? It is continuous in, for example, we want to find f plus g, that is sin x plus box of x, and this function is defined to be when say x equal to 0 to 1, 0 less than 0 less than 1. Now this value box of x will be, what is the value of box of x? It is 0. So this function will be defined as sin x itself. When x lies between 1 to 2, when x lies between 1 to 2, then box of x will be 1. So this value will be sin x plus 1. Now what is the definition of continuous function? Continuous function means left hand limit and right hand limit should be same, as well as function value should be same, and it should be a finite number. Now when we observe, what is this value? Sin of at x equal to 1, this value is sin x plus 1. Here left hand limit becomes sin x. That means obviously these two are unequal. So what we can observe? F plus g will always be a discontinuous function. Whenever we have added a continuous as well as a discontinuous function, its result is always discontinuous function. Second one, similarly you can tell about subtraction, but subtraction may or may not be discontinuous. If f of x is continuous and g of x is discontinuous, then what about the product? F of x is continuous and g of x is discontinuous, then the product f of x into g of x is not necessarily discontinuous at x equal to a. We will understand with another example. How is this condition possible? Sir, f of x is continuous and g of x is discontinuous. Let's take an example. I will just give the function directly. Easier way to understand this property is, let's take f of x equal to 0, g of x equal to box of x. Obviously box x is discontinuous function. Between 0 to 1 it is 0, between 1 to 2 it is 1, between 2 to 3 it is 2. So obviously g of x is a discontinuous function and f of x is a f of x equal to 0. What is this function? It is a constant function. So this is a continuous function and discontinuous function. When you multiply these two, what is the product? It will always be 0. Between, say, at 1.5, what is the value of f of x into g of x? It is 0. At 2.3, it is again 0. At 2, it is again 0. That means this is actually a constant function. When you multiply, its product is always 0. That means it is a continuous function. So whenever f of x is continuous and g of x is discontinuous, its product function is not necessarily discontinuous. That means it can be discontinuous or it may not be discontinuous. For example, f of x equal to x, then x into box of x, that will be a discontinuous function, right? If f is continuous at a and g is continuous at f of a, then g of f is also a continuous function. If f and g are continuous functions at a, then f of a g and g of f is also continuous at a. That is, composition of function will also be continuous. When two functions are continuous, its composition is also continuous. A function is said to be discontinuous in an interval if it is discontinuous at least one point of the interval. This is very, very important. This is a definition of continuity over an interval. So when we say a function is continuous over an interval, that means it is continuous at all points in the interval. This is this property. If at least one point there is a break, then we can say this function is discontinuous. Continuity in an interval. Continuity in an open interval as well as closed interval. We can discuss two cases. What does that mean? Continuity in interval. That means, let's take a function like this. And interval is between, say, this point is A and B. Can you tell if this function is continuous or not? Obviously it is continuous, because between A to B at all points this is a continuous function, so it is a continuous function. So continuity in open interval means excluding these two values, excluding A and B, at all other points we have to check the continuity of the function. So continuity in an open interval, that means function is said to be continuous in an open interval if it is continuous at each and every point in the given interval, that is open bracket A to B. For example, y is equal to box x, that is continuous on 1 to 2. Obviously box x is, what is the value of box of x between 1 to 2? Greatest integer, suppose x equal to 1.7, then box of x will be 1, f equal to x equal to 1.9, again box of x equal to 1, x equal to 1.00001, again box of x equal to 1. So this is a continuous function in the given interval. So box of x is actually a discontinuous function. It depends on what interval we are seeing. Suppose analyze the continuity of box of x in the interval between 1.5 to 1.9. That means it is a continuous function, because at all points in the interval it is continuous. That is the definition of this continuity over interval. Now continuity on a closed interval. Now this is very interesting, because in an open interval we are not considering the endpoints, because that is excluded. We are only caring about the inner values of the function. So if the function is continuous between those two values of extreme points, then we can say this function is continuous in an open interval. What about closed interval? Here comes the trick, because endpoint is also included. We will take one example, two examples. This is one function. We have to check the continuity in this closed interval between A to B, where A is here, B is, A and B are defined like this. In another example, let's change the definition of B at the point B, f of B to some other value. Then from these two examples, can we analyze if this function is continuous or not? What is your guess? First one is continuous function. Why is that? Because at all points in the interval it is continuous. That means it is defined in open interval. And then what we need to see this value f of a. If it is also equal, then we can say this function is continuous. So what is the definition for continuity in a closed interval, students? This function, we don't need to care about the left hand side of this function, because we are only caring about the closed interval between A to B, if it is continuous or not. So what we need to see is, see the function value, if it is continuous in all points in the interval, just like in how we discussed for continuous function in an open interval. So it is continuous in all points in the open interval, and then that value should match with the function value at the end point. So what is the value of this? F of a. X equal to a, this value is f of a, and f of a should be equal to limit of f of a, limit of f of a. That means f of, what is the limit that is possible here? From right hand side alone this function value is considered. So what that means is, right hand limit of f of x should be equal to function value at f of a. That is the definition for this. Similarly, what about this case? Here again, from the left hand side we are approaching the function. So left hand limit should be equal to function value. That is the only criteria for continuity at the endpoints in the interval. In general, what we do, left hand limit, right hand limit as well as function value should be considered. For a closed interval, we only care about endpoint is given, we are restricting the domain, so we are not caring about the other side of the graph. So within that graph, if it is continuous or not, obviously f of a is equal to right hand limit, here f of b is equal to left hand limit of the function, so this is a continuous function. And what about this? Right hand limit values, left hand limit value is coming out to be this value, and f of b is another value. That means this is a discontinuous function. That is how we should check for continuity at the endpoints in a closed interval. Okay, a function is said to be continuous in a closed interval if function is continuous at each point in between open interval of a to b. That is what we said. This condition, open interval condition, should be satisfied, and value of the function at b is equal to left hand limit of b that is f of b is equal to left hand limit of f of x, and value of function at a is equal to right hand limit. So limit f of a equal to limit x tends to a f of x. For example, y is equal to sin x is a continuous function on closed interval between minus 2 pi to 2 pi. Now what we need to see, f of minus 2 pi should be equal to right hand limit. Similarly, f of 2 pi should be equal to left hand limit of sin x at 2 pi. So when that is satisfied, obviously it is satisfying. So this is a continuous function. A function is continuous at x equal to a, choose the option from this. When we say function is continuous, right hand limit should be equal to left hand limit should be equal to function value. So what is the option, students? This is right hand limit equal to function, left hand limit equal to function value, right hand limit, left hand limit is equal to function value. So option 1 is the correct answer. All these three should be satisfied. Here in the question we are discussing continuity at a point. So at a point all the three values should exist and these values should be equal. F and g are continuous functions at x equal to a, then which of the following is true? C into f of x is continuous, f plus g is continuous, f into g is continuous, all of the above. Obviously this is the property we have discussed this. So what is the option? All of the above. Product of scalar with the function, that is continuous. F of x equal to sin x, 2 sin x is also continuous. F plus g is continuous. When we add two continuous function, it is also continuous. Product is also continuous. So it is all of the above is the correct answer. Show that f of x equal to box of x is continuous at only those real numbers which are not integers. We have already seen the graph, we have observed. So how to prove this? By taking the limiting value and see. We will discuss with the solution itself. Let a be any real number, then as long as a is not an integer, we have to prove this is only continuous at those values which are not integers. So if a is not an integer, that means box of a is not equal to a. Obviously box of 1.3, that is equal to 1, that means box of a is not equal to a as long as a is not an integer. Now what is the property of greatest integer function? Greatest integer function property is box of a is less than a, which is less than box of a plus 1. This condition will be used when a is not an integer. Yes, because box of a will be lesser than that value and this a will be lesser than box a plus 1. Because we can't say box of, say number is 2.5 and box of a is 1. That is not possible. So this a will always lie between box a to box a plus 1. Suppose box of a is equal to some integer k, then f of x is equal to k, that is true. This is for all x in between k to k plus 1. What does that mean? Suppose box of a equal to 2. That means f of x equal to 2 in between 2 to 3. That is the meaning of this statement. Yes. So on which interval f is continuous? This f will be continuous in between these two values. Thus f is continuous on between k to k plus 1. That means this is the proof for box x is continuous at only those real numbers which are not integers. In particular, f is continuous at a. Okay, if a is an integer, first we have discussed if a is not an integer, it is continuous function. Now what about integral values? When a is an integer, then limit of a plus, that will be, suppose a is an integer, we will take a equal to 2. Then limit of a plus, that is 2 point some number f of x, that will be 2 itself. And limit of a minus f of x. What is f of x here? Box of x. So that means limit of x tends to 2 minus, that is 1.999 f of x, that is box of 1.9999, that will be 1. So these two limits are not equal. So if this is a, that value will be a minus 1. That means left hand and right hand limits are not equal, hence it is discontinuous at integral values. Thus f of a does not exist and this function is discontinuous. Remember whenever we talk about continuous functions, it will always be continuous when all the three conditions are satisfied. That is, limit value should be equal to function value. Left hand limit, right hand limit and function value. All the three should be satisfied. Show that f of x equal to sin x is continuous on R. X equal to a, limit x is sin a. This is given. So f of x equal to sin x is continuous on R means we can observe from the graph, that is the easiest way. And mathematically how to prove that? By observing what is the limit limit x tends to a minus and a plus. A minus sin x, a plus sin x, that is equal to sin a. This is equal to f of a. That means this is a continuous function. Easy. We already know sin x cos x is continuous in all real numbers. Show that f of x equal to cos of x square is continuous on R. Now this is we can consider composite property because cos of x square, we don't know its graph or anything. So what we can do is take the one function as x square, h of x equal to x square and g of x equal to cos x. Then what will be g of f? G of h. G of h will be cos of, in place of x we are going to substitute h, that is x square. So this will be cos of x square. Now remember what about we learned about algebra of composite functions. When two functions are continuous, its composition is also continuous. That means when h and g both are continuous or not? Yes. X square is a continuous function, polynomial functions are continuous. Cos x is also, trigonometric function is also continuous and its domain is all real number. So both are continuous. That means its composition should also be continuous. So this will be cos of x square, that is equal to, this is a continuous function. F and g are continuous functions on R. So that means f, that is cos of x square, is also a continuous function. If f is a continuous function defined by, then discuss the continuity of f. If f is a function defined by this value, Then discuss the continuity of f. Okay, x is defined like this. Obviously, we know how to calculate limit. That plays a huge role in identifying, checking the continuity value of function. This is one type of question. X minus 1 by root x minus 1. Now by observation, in denominator we have root x minus 1. When we substitute x equal to 1, numerator and denominator both become 0. That means what we have to do? Try to rationalize or factorize this term. This can be written as root x square, x is root x square minus 1 square. That is in the form of a square minus b square. So what we can do is write this in terms of root x plus 1 into root x minus 1. This value becomes root x plus 1 into root x minus 1. Now root x minus 1 is a common term. X is greater than 1 and we are only going to check the limit of the function. So these values will get cancelled out. So when x is greater than 1, limit will be f of 1 plus, which means limit of x tends to 1 plus f of x. That is the meaning of it. So this value is equal to root of 1 plus, that will be 1, plus 1, that will be 2. And what about f of 1? F of 1 and f of 1 minus, f of 1 and f of 1 minus. This is a polynomial function which is continuous in all real numbers, and f of 1 is equal to f of 1 minus, obvious. This value is equal to 5 minus 3, that will be 2. That means f of 1 plus equal to f of 1 minus equal to f of 1 means this is a continuous function. All values are same. Now what about x equal to minus 2? At x equal to minus 2, f of minus 2 equal to f of minus 2 plus. This is right hand limit. So f of minus 2 function value and its right hand limit will be equal to, substitute x equal to minus 2 here. That means this will be minus 3 into minus 2 is 6 plus 5 is 11. Now what about x left hand limit? F of minus 2 minus, that will be equal to 6 by minus 2 minus 10, that will be minus 12. So this is minus half, which means left hand limit and right hand limit are not equal. So at minus 2 this function is discontinuous. At minus 2 this is discontinuous. At 1 this is continuous function. That is how we have to check the continuity of the functions. At 1 limit value is 2 as well as function value is also 2. So as limit is equal to function value, this is a continuous function. At x equal to minus 2, again this value is minus half and limit value is 2, right hand limit. So these values are not equal. As limit is not equal, limit does not exist means it is not a continuous function. Check the continuity of f given by this. Again this is similar question like previous. You can solve easily. At x equal to 2, this value is 0. What about 2 minus? At 2 minus, this value will be 4. 2 minus means we have to substitute 2 here. So 2 minus will be 4 minus 4, 0 by 2, that is 0. That means left hand limit and function value is equal. F of 2 minus is equal to, what is f of 2 minus? Half of 2 square minus 4, that will be equal to 0. And f of 2 is also 0, f of 2 is also 0. And what about f of 2 plus? F of 2 plus, that is equal to, substitute 2 here, that will be 2 minus 8 into 2 power minus 3. What is 2 power minus 3? 1 by 8. So these two will get cancelled out. This will be 2 minus 1, that is 1. So here f of 2 minus and f of 2 are equal, but f of 2 plus right hand limit is not equal to this. That means this is a discontinuous function at this value 2. So right hand limit is equal to 1, left hand limit is 0, function value is also 0. So as right hand limit and left hand limit are not equal, this is a discontinuous function. Again, show that this is a continuous function where a and b are constants. We have to prove this is a continuous function. Now how to prove continuity of this function? Limit should be equal to function value. That means here only change in this piecewise definition is at x equal to 0, this function is defined differently. So what we need to do is, we have to check the continuity at this point. We have already given, okay, this is a prove that this is a continuous function at x equal to 0. That means f of 0 minus f of 0 plus all should be same. F of 0 is given by b square minus a square by 2. And what about when x is not equal to 0? That means limiting value of the function should be equal. That means substitute, find the limit of this cos of a minus ax minus cos bx divided by x square. Let f of x equal to this value for x is not equal to 0. We will consider find the limiting value of this. Limit x tends to 0 f of x and x tends to 0 cos ax minus bx by x square. Now what is the formula? Cos c minus cos d. We have already learned what is cos minus cos, minus 2 sin sin. Add the value divided by 2, subtract the value divided by 2. So what is the answer? Limit x tends to 0, 2, add the value ax plus bx divided by 2, subtract the value bx minus ax. We have to reverse. It is minus 2 sin sin. Here as minus is not here, so sin of minus x is minus sin x. So take the second number minus first number divided by 2. That is given here. That is, here we can take x is common. This will be a plus b by 2 into x. Sin of again b minus a by 2 into x. Now in denominator we have x square. We can split this x into x in two terms. Now why do we need to split? Because when we apply limit of f of x into g of x can be written as limit f of x into limit g of x. We know the property for limits. So that means, and also we know sin of some number 0 divided by same denominator will become 1. So here what we have, when we substitute limit 0, that means sin of 0 is there, and what is this 0? This is a plus b by 2 into 0. In denominator we only have x. That means what we need to do, multiply and divide by this same coefficient in the denominator. Same is applied for here. So this will be equal to 2 times of, this will be multiply and divide by a plus b by 2. So in numerator we will have a plus b by 2, in denominator a plus b by 2, and this value will become 1. This sin x by a plus b by 2 into x, this value will become 1. And this value is again sin of b minus a by 2. So divided by b minus a by 2 into b minus a by 2. So this will also become 1. That means this limit will become 1 and we only have constants. That means we can multiply what is a plus b into b minus a, that is b plus a into b minus a is b square minus a square, divided by 1 2 will get cancelled, so we will have b square minus a square by 2. So limit value is equal to function value. So f of x is continuous. Next, last question. Check the continuity of the function f given by this. At x equal to 1 and at x equal to 2. Now at x equal to 1 and at x equal to 2, at the point x equal to 1, what is the limit? Right hand limit is given by this value 2x. That means it will be 2 into 1, that is 2. 2 into 1, that is 2. What about left hand limit? left hand limit is given by, what is the function here? Function is x plus 1, 1 minus that is given, that is in this interval. So we have to take x plus 1. That will be limit x tends to 1 minus x plus 1. That will be again 2. 1 plus 1, 2. As this value f of 1 and these values are equal, that means it is a continuous function. So limit value, left hand limit, right hand limit and function value is equal. So f of x is continuous at x equal to 1. Now checking for x equal to 2. At the point x equal to 2, limit value is, limit right hand limit will be, function is defined as 1 plus x square. So when we substitute 2 here, it will be 2 square, that is 4 plus 1, 5. And what about 2 minus? That is defined as 2x. So it will be 4. Which means limits are not equal, hence it is discontinuous at this point, x equal to 2. Okay, last question. Find the constants a, b so that this function given by this at the point 1, 3, 0 is continuous. It is continuous at this point. It is continuous at these points. Very easy question. We can solve in less than 1 minute actually. What is the observation here? When we have to find the constant. This is another type of question that can be expected. What they will ask in your questions boards means they will ask to prove if a function is continuous or not. That means we have to calculate the limits and function value and check. That is what we have discussed in previous examples. Now the next type of question can be, they have given the function is continuous and we have to check or find the value of some a and b, alpha, lambda, some constant values. So here sin x, x square plus a, bx plus 3 and minus 3. They have defined a piecewise function like this and we have to, and they have also given this function is continuous at 0, 1 and 3 and we have to find the value of a and b. Find the real constants a and b. Very easy students. We just have to apply the definition. The entire chapter of continuity is all about only one definition. Right hand limit, left hand limit and function value. Those should be equal. That is it. So here at 0, 1 and 3 this function is continuous means we will find function value and left hand limit. F of 0 minus that will be equal to f of 0. That will be this function, that is sin of 0 which is 0. Now what is right hand limit? 0 plus will be 0 square plus a, 0 square plus a, that is equal to a. As these two values should be equal, which means a should be equal to 0. Clear na? Left hand limit equal to function value equal to right hand limit. That means as these values should be equal, that means a is equal to 0. Now how to find the value of b? Again we will take 1. We will consider this, or we can take this example also, or we can take 3 also. Okay, we will take 3. What about f of 3 plus? That is right hand limit. So after 3, this value will be minus 3. And what about f of 3? That will be equal to, f of 3 will be defined by 3b plus 3. Yes or no? Yes. As these two values should be equal, which means 3b plus 3 is equal to minus 3. Which means what is the value of b? 3b is equal to minus 6. Which means b should be equal to minus 2. That is it. So what are the values of a and b? A equal to 0 and b equal to minus 2. So at 0, its value is 0. So a equal to 0. What about value of b? 3b plus 3 is minus 3. B equal to minus 2. So a equal to 0 and b equal to minus 2. Okay students, until now we have discussed what is continuity, definition of continuous function. What is continuous function? When we draw a graph without lifting hand from the paper, we can tell that function is continuous. And what is the condition for continuity? Left hand limit, right hand limit and function value should be 0. And we have discussed graph of continuous function, algebra of continuous function, what are the types of discontinuity, removable and non-removable discontinuity, and solve some examples for continuous function for better understanding. From the next class, we will discuss what is the differentiability and how to find differentiation of different functions. And keep learning and keep growing students. Success is yours line by line. Endigu endendigu namma tapasya.